In this particular presentation, I will be talking about 8086 instruction formats. The subject is Microprocessor, KCS 403. I'm Gaurav Parashar from the Computer Science Department. The basics of the instruction formats we'll be discussing in this current presentation. Now, what's an instruction format? Basically, a machine language instruction format has more than one field. For every instruction that is executed by the 8086, an instruction format is available that is binary representation of that instruction. This instruction format can be coded from 1 to 6 bytes, depending upon the addressing modes used for the instructions. Now we'll see the basic diagram of the instruction format. Now this is the diagram of the instruction format. Now, as you could see over here, that this entire instruction format is basically divided into several parts. The first part is the output, which has a size of 6 bits. We have D, that is direction, that's of 1 bit. We have W, word, that is of 1 bit. We have mod, 2 bits. Register, REG, 3 bits. ROM, 3 bits. Now we'll discuss about each and every particular field in bit detail. Now let's talk about what actually is an opcode. The opcode actually stands for the operation code. So every instruction has a unique 6-bit opcode. For example, the opcode for MOV is 10010. So that comes to be 6-bit 1, 2, 3, 4, 5, 6. So this is 6-bit format of the opcode. Now come to D. D stands for direction. Now direction means that whether the data is coming from the register or to the register. So if D is equal to 0, then direction is from the register. And when D is equal to 1, then the direction is to the register. Now next particular field is W. W stands for word. So if word is equal to 0, that is W is equal to 0, then only a byte is being transferred, and that is 8 bits. And if W is equal to 1, then a whole word is transferred, that is of 16 bit. So we have to understand this whole thing, that is what actually is being transferred. 8-bit data is transferred, or the entire one word is transferred. Now coming to this mod and RM. Now mod and RM is actually calculated upon the addressing mode rather than upon the addressing mode and register being used in it. The REG stands for the register selected. So it is 3 bits, and actually it is used for selecting the particular register. The last, and these are two basic optional fields which I haven't mentioned in this diagram. So these are two last options, and these are optional fields. So the lower order displacement and the higher order displacement are optional. And the instruction format contains them only if they exist and displacement is in the instruction. And then that's all for this particular instruction format. Thank you.